This is section 3.7, inverse functions, part 2. And we're going to begin with finding the equations of inverse functions. In order to do that, we first have to make sure that the function is one-to-one. So once we verify that the function is one-to-one, this is how we will find the equation of the inverse of that function. So we've already done that. So we will replace f of x with y. And this may already be replaced. So if you already have a y equals that function, then you can skip that step. Then we will interchange the x and the y in the equation. That's right. Everywhere there's an x, you'll write a y, and everywhere where there's a y, you'll write an x. Then we will solve for y. And whatever we find that y equals, that is actually f inverse of x. So we'll replace that y with f inverse of x. Let's give this a try. The first thing I want you to note is that in A, this is a linear function, and we've already talked about linear functions. They are all one-to-one, therefore one-to-one. Now, there is one linear function, of course, that is not one-to-one, and that's a horizontal line, the constant function, but that is the only one. So obviously that's not this function in A. So let's go ahead and start up here with step 1. We've made sure that we have a one-to-one function. Now we're going to replace f of x with y. So y is equal to 2x plus 5. Now we're going to interchange x and y. So now I'm going to write x is equal to 2y plus 5. And now we're going to go ahead and solve for y. So solving for y, we have x. Whoops, I want to be in this other color. We're going to subtract 5 from both sides. And now I'm going to divide both sides by 2. So I will have x minus 5 over 2 is equal to y. Let me write that as y equals x minus 5 over 2. Therefore, f inverse of x is equal to x minus 5 over 2. Let's see if I can get that down there. So, get that to go up a little bit. So that's what we have. Okay, let's take a look at the function in B. And what do you notice about the function in B? This is the graph of our squaring function translated up to, shifted up 2 units. So we actually have a function that's not one-to-one. As you can see, this fails the horizontal line test. Therefore, not one-to-one, so f inverse does not exist. Pretty powerful. If the function is not one-to-one, and you haven't restricted the domain like we talked about in the first part of this section, then we can't find an inverse function. Let's go ahead and take a look at C. Now, you could always put this in your calculator and see that it does pass the horizontal line test. But I want you to think about something. If I take any number and I subtract 2 and I cube it, I am going to get a unique y value. So this function is one-to-one. You can also verify that while graphing. So step number 1 is replace f of x with y. or the step after verifying that it's 1 to 1. And actually, why don't I go ahead and show you what this looks like. This is the cubic function shifted to the right 2 units. So it looks something like this. And as you can see, this passes the horizontal line test. So this is 1 to 1. Okay? So now I'm going to interchange my x and my y. And now I'm going to solve for y. So I'm going to take the cube root of both sides. So when you take the cube root of something cubed, we are just left with what was under that root. Now I'm going to add 2 to both sides. And there you have it. F inverse of x is equal to the cube root of x, all plus 2. Okay? Let's take a look at D. This function is also 1 to 1. You can verify this in your calculator. We have a vertical asymptote at x equal to 4, and 3, 4, and you can go ahead and check that out, but I can kind of show you. It'll look something like this, and definitely passes the horizontal line test. So this function is also 1 to 1. This has 2 or 3 algebra steps that are extremely important. In fact, I'm going to go ahead and write this 1 to 1 check a little further over to the right because we're going to need a little room. Okay, we verified that it's 1 to 1. We're going to replace f of x with y. And now I'm going to interchange my x and my y values. So now I'm going to have a y in the numerator, a term with y, and a term with a y in the denominator. Now here I'm going to multiply both sides by y minus 4. And as you can see, I will have x multiplied by y minus 4 is equal to 2y plus 3. So I'm going to distribute this x. And remember, I'm solving for y. So any term with a y in it, I need to gather them on the same side of the equation. So I'm going to subtract 2y and add 4x to both sides. So I can do that one at a time. Let me subtract 2y from both sides first. Going a little bit too fast there. So we have xy minus 2y minus 4x equals 3. Now I need to move this negative 4x, so I'm going to add 4x to both sides. And we end up with xy minus 2y equals 3 plus 4x. Now, why did I gather the terms that had a y in them? So that I could factor it out. So we're going to have y, and I factored out a y, and I'm left with x minus 2 is equal to 3 plus 4x. Now I'm going to divide both sides by x minus 2. We arrive at y equals 3 plus 4x over x minus 2. So f inverse of x is that expression. Okay, so a couple pretty important steps in there that will need to be practiced. So we do need to take a look at that, okay? and practice that. Find the inverse of a function with a restricted domain. Let's take a look at this function. This is our square root function, and it is shifted to the left 5 units. And it looks something like this. And here we can see that x is greater than or equal to -5. That was the restriction. So we know that our y values will be greater than or equal to 0. So those are our 2 restrictions on f of x. And let's go ahead and take a look at f inverse of x. We might want to try to look at the graph of the inverse function as well. So I'm going to go ahead and let me redo that. Draw the line y equal to x. Oops. And this is what the inverse would look like. Of course, this point here is -5, 0. So this point here is 0, -5, and so forth. So we could draw that graph like that. So let's go ahead and find the inverse algebraically and then put some restrictions on it. So we begin with f of x equals the square root of x plus 5. We'll let f of x equal y. And I wanted to mention over here we do have a 1-to-1 function. So we will write that 1-to-1. Okay, so now let's interchange our x and our y values. And now we're solving for y, so we will square both sides. And then let's subtract 5 from both sides. So what we have now is y equals x squared minus 5. So f inverse of x is x squared minus 5. Now let's talk about some restrictions. We interchange the domain and range with the original function. So now our x values will be greater than or equal to 0, and our y values will be greater than or equal to -5. So we have to restrict this graph. Let me just show you real quick. This is just the square root function shifted down 5 units. But that's not a 1-to-1 function. We only want the part of the graph that has the x values that are greater than or equal to 0 and the y values that are greater than or equal to -5. But it's that restriction on f. So we will not use this part of the graph, and you can see this over here, not drawn as nicely, but that is that right side of the parabola. Moving on to some important facts about inverses. These are all just a nice review. If f is 1-to-1, then f inverse exists. The domain of f is the range of f inverse, and the range of f is the domain of f inverse. If the point AB lies on the graph of f, then BA lies on the graph of f inverse. And the graphs of f and f inverse are reflections of each other across the line y equal to x. To find the equation for f inverse, replace f of x with y, interchange x and y, very important step, and then solve for y. And this gives us f inverse of x. This is a really good summary. Okay, let's end this section with kind of a fun little problem. In example 9, we're going to be using functions and inverse functions to encode and decode a message. So they've asked us to use the one-to-one function f of x equals 3x plus 1 and the following numerical values assigned to each letter of the alphabet to encode and then decode the message meet me at 2. So a couple of things I wanted to tell you is that one-to-one functions one-to-one functions and their inverses in the real world are actually used to keep information secure. Functions are used to encode, and then the inverse function is used to decode. So it's kind of neat. Of course, they're much more complicated. In the real world, they use much more complicated functions. So let's begin. I first want to write that message out a little bit larger. And then we will come up with how this would be encoded, okay? So let's take a look here. M corresponds to 13, okay? So what we would write here, and let me go ahead and change colors here. So what we would write is, since M corresponds to 13 and f of 13 is 3 times 13 plus 1, that would be 40. So our first code would be 40. And there's our function up there, 3x plus 1. Okay, let's go ahead and look at E. E, one to circle M, corresponds to the number 5. And f of 5 is 3 times 5 plus 1, and that's 16. And we have another 16 and another 16. Let's go ahead and look at T. T in our table corresponds to 20, and f of 20 is equal to 61. Okay, I had another 40 here. So now let's look at A. A corresponds to 1, and f of 1, 3 times 1 plus 1 equals 4. That's 4. And let's take a look at W. Corresponds to 23. And f of 23 is 3 times 23 plus 1, and that's 70. And last, O corresponds to 15. And f of 15 is 46. Oops. So once you see this, so this is how meet me at 2 would be encoded. 40, 16, 16, 61, 40. But let me show how we could use the inverse to decode. So use inverse function to decode. Okay, so the inverse function, let's go ahead and write this out. We have f of x equals 3x plus 1. Let f of x be y. Interchange x and y. And now solve for y. And that's f inverse. So now, look at this. So if we took found F inverse of, let's say, 40, which would be right here. Let me just put a little. So F inverse of 40 is 40 minus 1 over 3. That's 39 divided by 3, which is 13. And you can see, here's 13 for M. So that's how you would decode. I'll do one more. What do we want to try? 16? F inverse of 16 is equal to 16 minus 1 divided by 3, and that's 5. And there you have it, 5, and this 5. So we use the inverse to decode. And that concludes this section.